Okay, here we're going to be looking at some graphs of these quadratics and interpreting the graph. So we got a little story here. Biologists discovered an invasive bird species on an island. The function f models the population size in hundreds of birds. For this species as a function of time in months after being discovered. And it says plot the point on the graph of f that corresponds to the number of birds. So let's underline that. What are they saying? Plot the point on the graph of f that corresponds to the number of birds in the population when the biologist discovered it. When the biologist discovered it. Down here I got my little jaybird, fly. Where were these birds discovered on this graph right here? Let's get a this purple marker, right? Okay, let's see. Right here at 0. So if we're looking down here on this horizontal axis, we got months. All right, so when do you think they're counting these months from? When would you start counting the months? Right? If you just discovered these birds, would you for some reason call that negative 2 months and just not start counting the birds for 2 months? That wouldn't make sense, right? Would you start counting the birds after a month or 3 months? When you start counting the birds is right here. It's our vertical intercept. 0 time went by when they first discovered the birds. So what they're asking for is the vertical intercept, and that's going to be right here. It looks like about 15, or no, like 16 is where that blue graph crosses the x-axis. Okay, I'm going to just do these 3 here. Biologists introduced a population of bacteria to a test environment. The function f models the bacteria size in thousands as a function of time and days after introduction. So plot the point on the graph that corresponds to when there are no more bacteria in the population. So here, if I get my little pointer here, over here's where we started. Here's bacteria. Looks like the same graph. Look, it starts at 16 right here. At 0 days, there was 16. What did they say? 16,000 bacteria. All right, and they were growing. They're getting bigger. More bacteria. More bacteria. It hits this maximum. Here's the vertex. If they said what was your maximum amount of bacteria, you'd say 18,000. If they said how many days went by before it hit the max, you would say 1. But that's not what they asked for. They asked when there's no more. So we got to see, where does the bacteria hit 0? Right over here. It's our horizontal intercept right there. So I'll grab my dot on the test. It's going to be just like this, right? You're just going to plot your point. You know what? I'll ask you probably to maybe I'll ask for you to write what the coordinates are. When x is 4, y is 0 right there. If we go back up to here, when x was 16, or I'm sorry, when x was 0, y was 16. How about this one? Let's erase this. Biologists discovered an invasive species of fish in a lake. The function f models the population size in thousands of fish for this species as a function of time in months after being discovered. Plot the point on the graph of f that corresponds to the time when the population reaches maximum size. So here's my fish right here. He's the most hated. So we're going to go to the max. What's to the max? That's our vertex. All right, so the biologist discovered these fish right here the first day when x was 0, or the first month. They started off at the 5,000. And the fish were growing and growing, and they hit their maximum up here. Here's the vertex, what we're looking for. Then it went down, and got to 0. So if you're looking for the max, well, there's a question, right? Did they say how many months went by before it hit its max? No, they told us to plot the point on the graph that corresponds to when the time the population reaches its maximum size. So that's going to be right up here. I'm thinking that's when X is 4 and Y is 9. There you go. That's all you got to do for these 3 questions right there.